we can have infinitely many rectangles which sit on the x-axis here, and they can be inscribed under this green curve. To determine the coordinates of C, we could define, first of all, the D coordinates x, 0. And thus the coordinates of C just will be x, e to the minus ex squared. But to determine the coordinates of C such that A, B, C, and D has maximum area, we need to formulate a formula for the area in terms of a variable x. Well, first of all, we can find it in terms of AD multiplied by DC. And AD is just twice the value of x, which we can say 2x, and DC is going to be this value here of e to the minus x, which is here, the coordinate of C. So I can just write that down, times e to the minus x squared. And now we find the first derivative, which is going to make it the first derivative 0. So dA over dx. We're going to be looking at a product rule because we've got two separate functions over here. So we'll let u equals to 2x and u dash equals to 2. And v is e to the minus x squared, and v dash is equal to minus 2x e to the minus x squared. And as u dash v plus uv dash, using that formula, we can now substitute 2 e to the minus x squared plus 2x minus 2x e to the minus x squared. Simplify this down, and when we look here, we notice that these two can be taken out, so that we have e to the minus x squared 2 minus 4x squared. More precisely, I could have taken 2 out as well. Not that it would matter much in the scheme of things, but it might look nicer. Okay, now we need to make this derivative equal to 0. So let's have a look at how we can make it equal to 0. First of all, if I have a look at this part over here, and then I'll separately examine this part over here, because they are a product of those two parts. Either one of these can be made 0 to make this derivative 0. What would I need to do to make this 0 first of all? If I bring down this curve down here and you look at it, that is the curve y is equal to minus ex squared. That curve, as you can see, will never be 0. There's no value for x for which this formula will be ever 0, or this function will ever have y equal to 0. So we're going to look into this part over here, y minus 2x squared. There are possibilities there because we can say 1 minus 2x squared is 0, which means that 2x squared is equal to 1. So x squared is equal to a half, and x can have a value of 1 over root 2. And this has to be a positive value because we're dealing with length again, so x has to be greater than 0. It cannot be negative. Now we do a sign diagram. That's our next step for this particular dA dx. With this value here, 1 over root 2. And we need a restriction because we know that x cannot be anything below 0. And we know from the graph that x can go into infinity. Okay, to find out what the sign is, we'll just use some number between this interval over here, a very low one. Or if we insert it into our dA here, we know that the value is always going to be positive. So let's put it in here. And if we've got a really low number, you can tell that that's going to be 1 minus a very, very low number. So that's going to be positive also. All in all, it's going to be a positive value here. And the same will apply to the other side. If we use a number in this area over here, anything which we'd like, we will get a number which is going to be a negative number. This indicates that turning point is maxima over here, and we can draw this. So we know that we have a maximum value when x is equal to 1 over root 2 will give us a maxima. In that case, the y value will be, if we insert it into our thing, will be a minus 1 over root 2 all squared, which is really e to the minus a half. And in conclusion, the coordinate of C is going to be 1 over root 2, comma, e to the minus a half. And that is our answer for the year.